Okay, good afternoon, friends. Today we start new paper 314 Organic Synthesis. I am Sandeep Dhotre, MSc Organic Chemistry in 2011, and I am here from 7 years. So let's start our syllabus, organic synthesis. So organic synthesis, in organic synthesis we are going to start the oxidation, then reduction, then next topic is reaction intermediate, and after that the intermediate form in the reactions, during the reactions. So first upon we start the oxidation reactions. So in the first topic we start oxidation. So you know very well what is the oxidation. You already studied the oxidation in third year. So oxidation means what? The addition of oxygen and removal of hydrogen. Addition of oxygen and removal of hydrogen is called oxidation, or in other words, loss of electron by some species is also oxidation reactions. Means oxidation is either addition of oxygen or removal of hydrogen, or in other words we can say oxidation is loss of electron by some species or by some compounds. If it lost one or more electron, then the reaction is oxidation reactions, or in another words, increase in oxidation numbers, increase in oxidation number of one of the elements, their atoms in a compounds, is also oxidation reactions. Okay, all these are loss of electron, increase in oxidation number, all these are inorganic related oxidations. Now here we are going to start organic chemistry, means addition of oxygen and removal of hydrogen, loss of hydrogen. Okay, so first we are going to start oxidation of alcohol. So what is the alcohol? ROH is called alcohol, and this alcohol on oxidation, see here, if we see the oxidation of alcohol, so alcohol is oxidized to aldehyde, ketone, or in carboxylic acid. So primary alcohol, if there is a primary alcohol, then the primary alcohol is oxidized to aldehyde or carboxylic acid. Means first of all, the primary alcohol is oxidized to aldehyde, and aldehyde further oxidized to carboxylic acid. And if there is a secondary alcohol, then this secondary alcohol is oxidized to ketone. So secondary alcohol is oxidized to ketone. Okay. Now what are the reagent? Which reagent is added for this oxidation? So these reagent which added for this oxidation are called oxidizing agent. So there are different type of oxidation which oxidizes primary alcohol to aldehyde, or aldehyde further oxidized to carboxylic acid. Here we see one by one oxidizing agent. Jones reagent, Sorn oxidation, then Collins reagent, Pentyjones reagents, pyridinium chlorochromate, PCC, PDC, all these are the oxidizing agents. So some oxidizing agents are strong oxidizing agents and some are mild oxidizing agent. So those are the strong oxidizing agent. This oxidizes primary alcohol to aldehyde and further aldehyde to carboxylic acids. For examples, the reagent, that is oxidizing agent, such as K2Cr2O7 acidified, means in presence of dilute H2SO4, potassium dichromate oxidizes primary alcohol to aldehyde and it further oxidizes aldehyde to carboxylic acid. Aldehyde to carboxylic acid. Again, if we use same reagent, potassium dichromate in dilute H2SO4, then again this alcohol, secondary alcohol is oxidized to ketone. Again, if you want to oxidize this ketone to carboxylic acid, it is also possible, but only at drastic condition, means after long heating or strong heating, after long time or strong heating, again by using the same oxidizing agent, that is K2Cr2O7 dilute H2SO. Okay. So by using this strong oxidizing agent, ketone is also oxidized, but only in the condition, it's strong heating conditions, means drastic conditions. At the drastic condition, high drastic conditions, see here, in case of aldehyde, RC double bond OH. Now in case of oxidation of aldehyde to carboxylic acid, there is a breaking of CH bond, but in case of oxidation of ketone to carboxylic acid, there is breaking of this carbon and this alkyl carbon. So breaking of carbon-carbon bond takes place in ketone, and here in aldehyde there is a breaking of CH bond. So for the breaking of carbon-carbon bond, in case carbon-carbon bond, there is more energy is required to break this carbon-carbon bond, and therefore at high temperature and for the long time the oxidation is carried out, and after that this ketone is getting oxidized to carboxylic acid. Okay. Now if we use a strong oxidizing agent for the primary alcohol, it oxidizes to aldehyde and it further oxidizes to carboxylic acid. But if we have to stop this reaction at aldehyde, then we have to use mild oxidizing agent such as PCC, PDC, pyridinium chlorochromate and pyridinium dichromate. These are the mild oxidizing agent. Yeah, other Jones reagent, yeah, Swern oxidations. This Swern oxidation, the reaction is stopped at the aldehydes. If we use a strong reagent, then the aldehyde is further oxidized to carboxylic acid. See here, in all these cases we are adding oxidation, that means addition of oxygen. So here the single bond O is converted to C double bond O, that is oxidation. Again here addition of carboxylic acids, formation of RCOOH, addition of again oxygen. So it is again oxidation reactions. Again here C double bond O formation, that is oxidation. Again addition of COOH, that is carboxylic acid. Again there is addition of oxygen. So all these are oxidation reactions. Okay. So let's see the different reagents for the oxidation with the help of examples. See here, we take a simple examples of ethyl alcohol, CH3CH2OH. Now it is ethyl alcohol, or it is also called ethanol. Impact name is ethanol. This ethanol is oxidized by using strong oxidizing agent. We take a strong oxidizing agent as K2Cr2O7 and dilute H2SO4. So by oxidation, this alcohol get oxidized to aldehyde, that is formation of CH3 C double bond OH. Acetaldehyde. It is a common name, or ethanol. Ethanol is converted to ethanol, IUPAC name of aldehyde is ethanol. Again, this ethanol get oxidized by using K2Cr2O7 dilute H2SO4. In this presence of oxidizing agent, this is oxidized to CH3C double bond O OH acid. Which acid? Acetic acid or ethanoic acid. Ethanoic acid. So this is the simple oxidation of alcohol to aldehyde, aldehyde to carboxylic acid. Now another strong oxidizing. These are the strong oxidizing agent. So which oxidizing agents are strong? This acidified K2Cr2O7 dilute HNO3, then alkaline acidified KMNO4. So all these are the strong oxidizing agent, and this oxidizes alcohol to aldehyde, aldehyde further oxidized to carboxylic acids. Let's take another examples for the secondary alcohol. CH3CHOH CH3. It is propane-2-ol or isopropyl alcohol. Propane-2-ol or isopropyl alcohol. It is again oxidized. Let's take a same oxidizing agent K2Cr2O7 dilute H2SO4. Again, this secondary alcohol oxidized to ketone, that is CH3C double bond O CH3, that is acetone, propanone. IUPAC name is propanone. Means here, what is the oxidation? Removal of hydrogen from this oxygen and removal of hydrogen from the carbon. So if we add oxygen, so one hydrogen from the carbon, one hydrogen from the oxygen, and oxygen it removes as H2O. Here also we take oxygen, removal of minus H2O, we can write minus H2 or as a plus H2. Okay. Then again, if we have to oxidize this ketone to carboxylic acid, then again there is same oxidizing agent, that is K2Cr2O7, but this oxidation is carried out at drastic condition. This oxidation is carried out at the drastic condition, means at strong heating for the long time, means heating these reactions, breaking of the carbon bond. So carbonyl carbon and CH3 carbon break here during these reactions and formation of CH3COOH. Now this CH3 is removed as a CO2. This CH3 is removed as a CO2, and if there is a large chain, then according to the Pope's rule, there is a breaking of carbon-carbon bond in which the carbonyl group is along with the small alkyl group. This carbonyl group is remain with the small alkyl group. For example, if there is a formation of ketone CH3C double bond O CH2 CH3 from the pentane-2-ol CH3CH OH CH2 CH3. If we oxidize this, we get this ketone, and when this ketone is further oxidized by using strong oxidizing agent K2Cr2O7 in dilute H2SO4, that is acidified K2Cr2O7, again here this ketone get oxidized to carboxylic acid, but during the oxidation, which carbon-carbon bond break? Either this carbon bond break, or either this carbonyl carbon or this CH2 carbon bond break. Here, what is the Pope's rule? According to this Pope's rule, the breaking of carbonyl take place along with small alkyl group. Now here small alkyl group is methyl, and this propyl large alkyl group. So breaking of carbon takes place at this site. Means along with the small alkyl group, the bond of carbonyl remain with the small alkyl group, and therefore we get CH3COOH acetic acid. Again, these three carbon get oxidized to acid. It forms the propanoic acid CH3CH2COOH. So we get two acids from the ketones. According to the Popov's rules, here the breaking of carbon-carbon takes place in such a way that the small alkyl group remain with carbonyl. Okay. So this is the simple oxidation by using strong oxidizing agent. Okay. So primary alcohol is oxidized to aldehyde, aldehyde to carboxylic acid. Secondary alcohol oxidized to ketone, ketone further oxidized to carboxylic acid. But see in this example, here the number of carbon is 2 carbon. In aldehyde there is also 2 carbon, and in carboxylic acid there is also 2 carbon. But in case of secondary alcohol, here alcohol contains 3 carbon alcohol, and in ketone again there is 3 carbon, but in carboxylic acid there is 2 carbon. So we can say here that this is the distinguished test for aldehydes and ketones. By using a strong oxidizing agent, we can distinguish primary and secondary alcohol. We get last product is the acids. If the number of carbon in alcohol and in acid remains same, then it is primary alcohol. And if the number of carbon in alcohol and the number of carbon in acid is different, means the number of carbon is less in carboxylic acid, then the starting alcohol is secondary alcohol. Okay. So this is a general simple oxidation of primary and secondary alcohol. Now we have to study here the different oxidizing agents which oxidizes primary alcohol to only at aldehyde and not to the carboxylic acids. This oxidation is also carried out up to the aldehyde if the reaction is carried out at the temperature of boiling point of aldehydes. Means the reactions is carried out at the temperature of boiling point of aldehydes. Means when we carry these reactions at the boiling points of aldehyde, as soon as the aldehyde is formed, it gets vaporized to gaseous state because the temperature is the boiling point temperature of aldehydes. It goes to the gaseous state, it collected as a gas and then compressed to form the liquids. So as it converted into gaseous state, it do not react or it does not oxidize to further carboxylic acids. So in this way we can stop the reactions at aldehyde by using the temperature. That temperature should be the boiling point of that aldehyde which is to be formed. Okay. And ketone, if we have to stop the reactions at ketone, not to the carboxylic acids, then here the temperature is lower temperature so that the reactions, and as soon as the ketone is formed, the reaction is stopped. The reaction is stopped at the ketone and there is no further oxidation of carboxylic acids, and the formation of ketone can be checked by using the TLC. So in first year you already studied the thin layer chromatography, which is used to know the whether the reaction is complete or not. Okay, I think we will stop here. We continue the oxidations of alcohol to aldehydes and ketone with oxidizing agents, which is given in your syllabus. Okay, thank you.